Hello again. So now I will start with the presentation from the experiences about farm level modeling, trade-off analysis, and multi-criteria assessment in the context of Latin America. Um, as you know, the project, the CLCA project, has been applied in Latin America, in Bolivia and Mexico, which are two countries or two regions that, even if within the same continent, they are very different, agroecology and culturally, but they have very many things in common. They have both of them. They have harsh climatic conditions. They are dry and cold. They are limited by temperature and by water. In the Bolivia highlands and in the Mixteca in Oaxaca, we have important erosion of soils. Most of there is an important rural population in both regions, and with important levels of poverty, malnutrition, and, as I said, the degradation of soils. In both systems, crop and livestock components are important for the farming systems and for the livelihoods of farmers. And they are competing for resources, for forage, for land, for labor, for investments. So these CA, conservation agricultural alternatives, have been promoted, but they have not fully been implemented by farmers, partly because of this nature of mixed farming systems, where they need to decide if they leave the residues for the soil or they give it to the animals, and how to find the optimum combination of resource management. So in both cases, research and development partners are willing to adapt CA technologies to these mixed farming systems and to scale them to a largest possible of farmers possible. So just some pictures to give you an idea on the farming systems in Mexico, where in Mexico we have basically maize-based farming systems with an important livestock component with sheep, goat, and cattle. In this case, we have an important outmigration, so labor and labor aspects are important. And in Bolivia, we have a quinoa llama system, where quinoa has had an amazing boom in terms of production, productivity, exports, and it has represented an important livelihood strategy for farmers in the southern highlands of Bolivia, where somehow llama has been displaced. So the equilibrium between llama and quinoa has been changed, and now we see important degradation of resources, important abandon of llama production, and super intensification of quinoa, with the consequences of degrading soils. And as you can see, it's a very arid area with very erosion-prone soils, mainly for wind erosion, because precipitation is fairly small. So in these two sites, we implemented farm-level analysis and modeling exercises. And the general approach was first to do a typology of farming systems to understand the diversity of farming systems. We use existing farm household data from our partners in Mexico, the Autonomous Metropolitan University in Mexico. They had a farm household survey. We developed a farm household survey for Oaxaca. And in Bolivia, we use a Procamelidos survey, which Procamelidos is one of the IFAD financed loans to develop the llama value chains. So with this farm household survey data, first we do a typology, first we do a descriptive statistics, and then through multivariate analysis based on principal component analysis and hierarchical clustering, we did a typology. based all this, as I showed in the previous presentation, based on a systems approach. And what it means by that, it means using variables that describe the system boundaries, no? What's the resources, how much land they have, how much animals they have, for example, and the system component. Then the system components, no? Which crops, which livestock species, which of non-farm aspects. No? We looked at the inputs and the outputs of the system, so fertilizer or market integration, selling crops or buying inputs, as well as the internal flows within the system, which is basically how manure is managed, how crop residues are managed, etc. Then we continued with a multi-criteria assessment, and we did it basically through farm household modeling. So in this multi-criteria assessment, we use several economic, social, environmental indicators related to both the integration of crop and livestock. And we used a model called farm design for modeling and assessing the performance of these systems. In principle, and we did it in Oaxaca at least, is that after the modeling exercise, we managed to get some feedback for farmers and use that modeling approaches to start a participatory approach where we discuss these modeling results, we identify potential options that can improve the performance of mixed farming systems, and we went into fine-tuning, testing together with farmers in farmers' fields and collecting data to be able to assess these different CLCA alternatives for different farm types. So basically, in this approach, first, what we do is this principal component analysis, where different variables are set into different principal components. So taking out the dimensions of different variables and grouping variables that are showing the characteristics of different groups. And we did this hierarchical clustering where we could identify fairly distinctive groups of farmers, which we will know if they are mainly a livestock farmer, mainly a crop farmer, a mixed farmer, mainly with off-farm or with little resources or with high resources, etc. So these typologies help us to identify the different types of farms that we are going to work with. So once we do the typologies, we try to identify, to characterize and depict the main farming systems in terms of their components, no? The land component, the livestock component, the farm household, the main inputs, the main outputs to the market, etc. And once we have these different types identified, we did parameterize a model called farm design made by Jeroen Groot, a scientist from Wageningen University, which is a model where all the different components, the household component, the animal components, the crops, the soil, and the manure are well described, and the flows between the different components are also quantified, so as to be able to assess different options in relation to multiple indicators. So the farm design model is a well-developed model that has an interface where we have the different windows in the model, where we first specify the system in terms of the crops and the livestock species and the different production levels. Then we see the flows within the different components of the system. So how much organic matter is flowing from crops to animals, to manure, to soils, etc., with the different losses. But it has also the possibility through a genetic algorithm to optimize the system and to identify through different indicators what are the optimum situations and what are the trade-offs possible between the different indicators. So this is a useful way to identify optimum solutions in which most of the indicators are in an acceptable level, So this is the model we use. You can look for farm design in Google and you will find the papers related to this model. You can also find the model itself and a very good manual they have made for the model so that you can parameterize for any farm. So this model, what it does is you do one farm. So we do a typology, then from that typology we see the different farm types. For that types we select one farm and then we model it very precisely in terms of the flows, how much they put into the different crops, what they did with the crops, what they did with the residues of those crops, what they did with manure, how they fed the animals, etc., etc. So with this kind of model, we can first do an assessment. For example, this is in Mexico, where we can see different indicators related to operating profit, to income, to the balances of organic matter, nitrogen, the greenhouse gas emissions, etc. Lots of different indicators that we can assess, in this case, in Mexico, for the different farm types identified in the typology. So we can see some of the types, like type 1 has a very good operating profit and very good economic performance compared to farm type 5, for example. But farm type 5 may have a very good performance in other indicators, like for example, I cannot see this one, but I guess is pesticide use probably, where we can see that this farm type has better performance. So the outer round is the optimum or the maximum level. And we can see which farms and which types of farms are performing the best in which indicators, and they are performing probably the worst in other indicators. So we can already identify which farm types can perform and how can we improve different farm types under which kind of indicators. The same we did for Bolivia. No? For the 3 different farm types identified, we parameterized the model and we could see that for one type of farm, very economic performing farm, no? But in terms of forage self-sufficiency and greenhouse gas emissions and other indicators, pesticide use, they are quite poor, while the farm type number 3 is performing much better while having a lower operating profit or profit-making situation. So we can see that different farm types have different performances in relation to different indicators, and this kind of analysis allows us to identify which kind of elements and alternatives we should be working for the different farm types, considering, as I said in the previous talk, that not everything is good for all types of farms, but we have to be able to target and tailor alternatives. So basically first target and then tailor and adapt alternatives to the specific situations and conditions. So one of the advantages of using this kind of modeling approaches is that it allows to analyze the trade-offs between different indicators for one farm. So for example, these are different indicators, no? Operating profit, leisure time, so free time, or organic matter, balance, nitrogen, phosphorus, greenhouse gas emissions, forest self-sufficiency, that we can see how do they relate to each other. And we can see some important trade-offs or synergies between. We can see a very evident one where we see, well, we increase the nitrogen balance, and yeah, we may increase the greenhouse gas emissions. But I would like to go closer to this area of the graphs so that you understand better what I'm talking about. So it didn't zoom very well, but anyway, I want to explain to you this graph with a bit more detail. If we look at the operating profit indicator and the organic matter indicator, so we want to increase organic matter and we want to increase operating profit. Now, what we see here is a very interesting and very illustrative example of how can we use these models. Is that the gray area is the So if you see, there is a little point, black point here, and that's the current management. So with current management, just by modifying the flows within the system and the different the land allocation to different alternatives, this is the current management, the black point, and we can see that we can improve the system. We can improve operating profit at the same level of organic matter, and we can even improve a little bit the organic matter. We can see that's if we see the gray cloud. Now, in the case of Oaxaca in Mexico, we experimented for 2 years with farmers. With here I put a picture of veg and oat rotation, so that to produce more forage for the livestock component. So when we experimented, we reanalyzed all the flows and all the performance of the different components, and then we got into this new situation, which is the little green point below this green wave, green area. So this is when after experimenting we passed from this black point to this green point. When we did the modeling and the optimization and the genetic algorithm, we can see that we can still optimize, improve the system. So we can still increase the operating profit and increase the soil organic matter. So moving up, increasing organic matter, and moving right, increasing operating profit. So we can still improve a lot the system in terms of operating profit. But if you see, there is a line that shows that there is a trade-off. There is a moment in which for every time we increase operating profit, we decrease our soil organic matter. So we have an optimum management that increases at the maximum the operating profit and keeps the maximum organic matter balance. If we go further, we may start increasing operating profit, optimizing, maximizing our operating profit, but we will decreasing organic matter. So this shows on the one side the effect of experimenting with one type of farmer on alternatives with forage production within the maize-based cropping system, and we can see the jump, how it improved. But we can say it can improve further the operating profit without sacrificing any kind of organic matter. We can see also that we will increase our nitrogen balance, and also we will increase the greenhouse gas emission possibility. So this kind of analysis allows us to see these trade-offs and identify where can we still improving, and how those trade-offs and how those relationships with other indicators need to be taken into account, so as not to only maximize one indicator, but to reach an equilibrium between the different indicators of sustainability. So I know it's a complex process and it's a complex methodology, but it's very useful. So I will try to just to finish to recall on the approach that we use from farm level analysis and modeling. We first use a farm typology, which is useful way to characterize the farm household diversity, identify the potential household types to implement the innovations that we are working, in this case conservation agriculture within the context of crop livestock systems, and target participatory experimentation and fine-tuning of alternatives, as we did in Oaxaca, where we experimented for a couple of years with these forage rotations within maize systems to see what will be the effect, what is the effect on different indicators. Now the modeling allows to have an holistic view of the farm performance by taking different criteria to identify then the most promising type alternatives for specific interventions, so types interventions, so a bit the recommendation domain that I was talking before. And important to identify these trade-offs between different indicators so that we know what are the the main elements that we have to see when we develop an alternative, that we don't make these trade-offs even more important, and we try to identify these optimum management strategies to satisfy all different indicators. So at the end, the most important aspect of this is the way how can we use modeling and participatory approaches in the co-development of knowledge, and then the appropriation of crop livestock conservation agriculture innovations through participatory research combined with modeling. So this is about the work that we have been doing in Latin America. I hope you find it useful. I hope you find it inspiring and enlightening in terms of the targeting and the need to understand multiple criteria, diversity of farming systems, so that we can move forward into the fine-tuning, adapting, and tailoring these alternatives for better systems, more sustainable, more resilient, more productive, and more efficient systems. Thank you very much.